Well, hello, everybody. Welcome back. Today we talk about functions, another one of my favorite topics. And actually, we've been using functions, we just didn't call them functions yet. So when you were doing your Build-A-Patterns and you came up with the rule is basically a function. So if you look at the top of your paper, we have a quick little definition here. A function, which is a word you need to know, is just a rule. Rule is just an equation, a formula. You could call it either one of those. Equation would probably be the best term since it's a very mathy kind of word that relates two quantities or two numbers, two amounts, so that we have what's called an input, which is the number we put in, which we talked about that the other day as well. And when you put in that one number, you will get out exactly one number. So they're kind of like partners. Every input has just one little partner to match up with, and that's the output. What makes something not a function is if you put in one number, but you might get out two different numbers, or three different numbers, or four different numbers. That's not a function. So the main idea is if you put one number into your equation, you will get out one number. So that those two will be little partners. Now, I like to think of it as a little function machine, and function machines have been around for a long time. All they are, it's just a little contraption. It looks something like this, very simple, where you have a little opening in the top, and this is the actual function machine that does all the works, the magic, and then out to the side is your output. So it's just a crazy little contraption that takes your input, finds what the output number is, and spits it out the side. So when you drop a number in, it sounds a little bit like this. We drop a number in, the function machine starts working hard and doing all that calculating, goes beep, boop, 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 beep, boop, boop, and spits out a number out to the side, which is your output. So how do you figure out what the output is? Well, when you put in a number, the rule or the equation is what determines what the output is. And remember, we said our input is the x value and the output is the y value. So remember, we've graphed some of these using our x and y coordinates to make our ordered pair. So let's take a look at an example, because that's what will make it a whole lot simpler. All right, so let's suppose we have the function y equals 3x plus 4. This is our function or our rule. And this rule, this equation, says if I put a number in for x, that's my input, and I multiply it by 3 and add 4, I will get my y value, which is my output. So let's say our input is 2, and most of the time you get to choose your input. So you can put in anything you want, whatever your little heart desires. So we're going to put in 2. Input is 2, which is our x value. So what will our output be? Well, we've got to do a little calculating here. So we're going to drop the number 2 into our input section of our function machine. Our function is y equals 3x plus 4. If we drop that in, we go y equals 3 times 2 plus 4. And that function machine starts working. It goes boop, 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 and it's going to spit out a number. But first, we have to figure out what that number is. So while it's boop, 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 booping, we have to do the math here. So 3 times 2, and don't forget your order of operations, would be 6. And then we add the 4. So y equals 10. So when I put in 2, I'm going to spit out a 10. That's, remember, y is my output. And there you go. So my output will be 10. So if we drop in a 2, we go boop, 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 and boop, spits out a 10. So we have an ordered pair of 2, 10. That would be a point on the graph of this function right here. And you've graphed plenty of functions with your Build-A-Patterns. Let's look at a different example. Let's suppose, and you can just jot this one off to the side here. Let's suppose we have our function of, let's take one that was in, in your Build-A-Pattern packet. So let's take a function of y equals 4x plus 8. That was one of our rules from one of our patterns. So let's put an input of, I don't know, what do you think? I know, let's try a negative number. Let's make it a little more interesting. Let's put an input of negative 3. So if I put in negative 3, remember x is your input, I'm going to say 4 times negative 3 plus 8. And now we plug and chug, drop it into that function machine. Oh, why don't we draw a little function machine in here? Why not? Just for good fun. There we go. There's our function. We have y equals, we dropped in a negative 3. Put it in. 4 times negative 3 would be, what? What is it? What is it? Oh, that's right, negative 12. Very good. And then we add 8 to that. And when we do that addition problem, we have 12 negatives plus 8 positives gives us 4 negatives. So if I drop in a negative 3 into this function machine for y equals 4x plus 8, it goes boop, 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 and spits out a negative 4 for my output. So that means my ordered pair, a point on this graph right here would be negative 3, comma, negative 4. And you could choose all kinds of numbers. We could try a different input. We could put in an input into that same function machine. We could choose 5. And so we would have our little function machine right here off to the side. I love these things. And like so, we have y equals 4 times 5 plus 8. Y equals 20 plus 8. So y equals 28. So if I drop in a 5, I'm going to get out a 28. So another point on this function, on this graph, would be the point 5, comma, 28. And I forgot to make my sound effects. So if I drop in a 5, it goes boop, 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 and spits out a 28. And there you have it, guys and gals. So, as we said before, functions, you have done officially now all of the different ways you could represent a function. It could be a table. Remember your T tables from your Build-A-Patterns where you had like wiggles on this side and toothpicks on this side? That's a T table or a table. And then you had numbers listed here. That's one way to show what a function looks like. You could graph it on a coordinate plane, which you have done. That's another way. Or you can write an equation and use that equation, which is what you did on your Build-A-Patterns too. This rule, formula, equation is a function. All right, and then the very last little piece, which is a term you need to know, it says a linear, that's pronounced linear, equation is an equation whose line is whose graph is a line. Linear, line, line. See that right there? Linear, line, linear. The beginning of that word is line, so that means it is a big fat hint as to what that graph's going to look like. So this graph will be a nice straight line. It could be horizontal, it could be very slanty, it could just be a little bit slanty, but it's a line, which means it doesn't curve and it extends forever in both directions. So a linear function is a function which could be an equation or a rule or a table or a graph. It has a graph that is what's called a non-vertical line. So that means a linear function can be any kind of line except this. Oh my goodness, that was a terrible line. Let's do this. I don't have all my arrows here, but this vertical line right here This is not a function. And this is the only type of line that is not, because it's a vertical line. Vertical lines are the only exception here. Vertical lines are not functions. So they have to go straight up and down to not be a function. Are not functions. Boom. Okay. If we had a line like this, that's a function. If we even have a line like this, that is also a function. And I'm going to attempt to draw one horizontally. Oh, ooh, that was pretty good. That would be a function. These are functions. Oh. Forget that. Let me go back here. These are functions. And these are not. Well, this one, vertical line only. So there you have it. Your next item on the agenda is to continue on to the next page, and you'll be drawing some very important conclusions about your Build-A-Pattern graphs. So, good luck, happy functioning, and let me know if you have any questions. See ya. Bye-bye.